This is lesson 5.9, chords and inscribed angles. In the previous lesson, we talked about the relationship between central angles and their intercepted arcs. In this lesson, we're going to talk about inscribed angles and their intercepted arcs. So if we look at the MDI today, we can see that what we're looking for is the measure of arc WVU. And remember that each of these three letters tells us something specific about the arc. So W tells us where our arc is going to begin. V tells us what direction we're going to go around the circle. And U tells us to keep going until we stop at U. So the arc that we're looking to find is this highlighted arc here that's in green. So there's a couple of different ways that we can approach it. Probably the easiest way is that in a circle we know that there are 360 total degrees. In this problem we know that this arc here, the part that's highlighted in orange, and the part that's highlighted in green have to add up to be 360 degrees. So if we take the part that's highlighted in orange, that would be 50 degrees plus 95 degrees, which is equal to 145 degrees. So in order to find what's in green, we could just take 360 minus 145, which is equal to 215 degrees. So we know that the arc WVU has a measure of 215 degrees. The other way that we could think about it actually adds a step onto this. If we add these three arcs here, 95 plus 50 plus 70, and then subtract that from 360, that will tell us the arc from V to U. And then from there, we can just add the 70 together with this arc over here, which would still end up being 215, but gives us an extra step to look at. On the second one, it's similar. This time we're looking for the measure of arc FH. And because there's only two letters here, we know that this is a minor arc. So a minor arc has to be less than 180 degrees. So we start at F, and we go in the direction that's going to make this arc less than 180 degrees. So if you think about going in the opposite direction, going this way would make this over 180 degrees, so we know that we have to go the short way. So if we highlight this here in orange, we can see that the green arc plus the orange arc has to add up to 360 degrees. So again, what we can do is we can add the arcs that are highlighted in orange. So if we take 125 and we add 80, we get 205. And remember that a central arc and its a central angle and its arc are the same measure. So if this angle in here is 125 degrees, then the arc itself is also 125 degrees. And the same over here. This angle here that's 70 means that this arc here is also 70. So now that we know that this orange arc is 205 degrees, in order to find the one that's highlighted in green, we just take 360, which is the total number of degrees in a circle, subtract out the 205, and we get 155 degrees in the green arc. Yesterday we talked about the relationship between a central angle and its intercepted arc. So a central angle has a vertex at the center, and the intercepted arc is this angle out, or this arc in between the two sides. So if we extend this side out here, you can see that the intercepted arc is in between those two sides. So if this angle right here is 38 degrees, then that means that the arc out here is also 38 degrees, and vice versa. So what we're going to do today is we're going to look at the relationship between an intercepted angle, or I'm sorry, an inscribed angle and its intercepted arc. So what we want to do today is we want to find the measure of an intercepted arc or its inscribed angle. So the first thing is that an inscribed angle is an angle that has the vertex on the circle. So you can see that this vertex is on the outside edge of the circle, and it has sides that are chords of the circle. So if you remember last lesson, we talked about a chord just connects 2 points on a circle. So if we have a point here, point D, and point A, this is the chord that connects those 2 points. If we have point C and point A, this is the chord that connects those 2 points. So these two chords intersect to form this angle right here. So the relationship between an inscribed angle and its intersected arc is that the angle, the measure of angle CAD, is half of the intersected arc. So whatever this arc is right here, we can take half of that to find what A is. So if the arc here is 80 degrees, we can take half of that to figure out what A is. Okay, so this is just saying it in words. The measure of the angle is half the measure of its intersected arc. The other way that we can think about this is to go the opposite direction. So we know that the arc is twice the measure of the angle. So if we know what the angle is, we can multiply it by 2 to find out what the arc is. So for example, if we know that this angle down here is 28 degrees, all we have to do is take 28 times 2, and that will tell us what this intercepted arc is. So remember, this is different from a central angle for a couple of different reasons. Number one, an inscribed angle has the vertex on the circle, whereas a central angle has its vertex on the center of the circle. And an inscribed angle is half the measure of its intercepted arc, whereas the central angle is exactly equal to its intercepted arc. So we've got these two examples that we can look at. Okay, if we know that this arc from A to C is equal to 120 degrees, we know that this angle is half. So if we know that the arc is 120 degrees, then that means that this angle is 60 degrees. So we can say that 4x is equal to 60, and then to solve for x, we just have to divide by 4, so x is equal to 15. On this one, we know what the angle is. The vertex is down here. We know that the angle is 63 degrees. What we need to figure out is x if this is our arc. So this arc right here, if we know that the angle is 63, the intercepted arc is twice as big. So if we take 63 times 2, that gives us 126 degrees. So that means that this has to be equal to 126 degrees. So to solve this, add 4 to both sides. 5x is equal to 130. Divide both sides by 5, so x is equal to 26 degrees. So using what we know about inscribed angles and intercepted arcs, we're going to use some examples now. So you notice that we have A up here. So A is the arc that goes from P to T. So we need to know what this arc is. And we also have an angle that's B, and we'll get to that one later. So the first thing that we want to do is we want to figure out what the measure of angle or of arc A is. So in order to find that, what we need to do is we need to find an angle that's associated with that intercepted arc. So if we take these two endpoints of this arc and we follow it back to where they intersect, we can see that this arc is intersected by this angle. And if the angle is 60 degrees, remember that an inscribed angle is smaller than its intersected arc. So if this is 60, then this number should be bigger out here. So we need to multiply by 2. So 60 times 2 is equal to 120 degrees. So on to finding the value for angle B. Angle B is this angle down here. So again, in order to find this angle, we need to figure out what arc it intersects. So if we follow this angle out to the circle, we can see that the arc that it intercepts goes from P to S. And we already know what the arc from P to T is. We know what the arc from T to S is. So if we just add those two together, we know that B is equal to half of 150 degrees. So the arc itself is 150 degrees. That does not mean that the inscribed angle is equal to that. It means that the inscribed angle is half of that. So if we then take 150 divided by 2, that would tell us that B is equal to 75 degrees. Example 2, we want to find the measure of angle 1. So if we look at where angle 1 is, that's an inscribed angle also because its vertex is on the circle. And if we follow the sides out, right, the intercepted arc is in between those two sides. So if we draw it out even farther, draw those sides out even farther, it might help you to see a little bit better that this is the arc that we're talking about. Well, this arc represents half of the circle. This is a diameter, so this is half of a circle, which means that this is 180 degrees in this arc right here. And since this arc is intercepted by angle 1, we know that angle 1 is half of 180 degrees, which is 90 degrees. So this is one of the big theorems that we're talking about. Any angle, I'm going to change this a little bit, any angle inscribed in a semicircle is a right angle. So again, you can see it doesn't matter where your vertex is, because as long as this part is the diameter of your circle, it's going to be opposite a 180 degree angle, so that's still going to give you a right angle here. So remember, a right angle is just a 90 degree angle.